All right, so today we're going to wrap up our graphs by talking about cosecant, secant, and cotangent functions. And these guys are even easier than the tangent graphs. So I think you'll enjoy taking a look at these guys. Okay? To get us started, I'm going to fast forward a little bit. I want to take a look at just a basic cosecant x graph. It's not in your notes, but I think it will go a long way in helping us understand why, what these graphs are going to look like, right? So first we have to understand that cosecant is the reciprocal of sine. And so hopefully not very surprising to find out that the cosecant graph is going to be sort of based off the sine graph. So let's take a look at graphing sine x really quick. And this should be pretty easy for us too, right? The amplitude is going to be 1. The period is going to be 2 pi, right? 2 pi divided by 1 is just 2 pi. And our x values, 2 pi divided by 4, so that's pi over 2. So we can go 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? But also, let's remember what those y values are, what those sine values are, each of those angle measures. Right, at 0, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, 3 pi over 2 is negative 1, and this was 0. Okay? And so, now, to get cosecant, so now we've got our values in for sine. To get a cosecant, to get our cosecant values, we just flip over the sine values, right? So at cosecant of 0, we're just going to take this guy and find the reciprocal. Remember that 0 as a fraction is 0 over 1, so the reciprocal would be 1 over 0. But you can't divide by 0. So cosecant of 0 is undefined. Right? Cosecant of pi over 2, if you flip over 1, you still get 1. Again, if you find the reciprocal of 0 is undefined. And the reciprocal of negative 1 is negative 1. The reciprocal of 0 is undefined. Okay? Now, remember what happened with tangent. When we got undefined values, we end up having asymptotes. Well, now we're going to have asymptotes for our cosecant graph. But where those asymptotes are becomes very interesting. So let's graph our sine graph first. And we know how sine goes. Sine starts at 0. And then it goes up to 1, then to 0 on the x-axis, then negative 1, then back to the x-axis. And if we go the other way, the pattern repeats, and we know this. Okay? But, again, at 0, if we start switching this graph over to cosecant, at 0, we're supposed to be undefined. So the moral of that story is, all of these x-intercepts are going to become asymptotes for the cosecant graph, because if we find the reciprocal of 0, we get undefined. So when we plot out the sine points, that means that everywhere we get an x-intercept is going to become an asymptote. So we turn all those x-intercepts into asymptotes. If you look at pi over 2, which is this guy, we can label pi over 2. This is pi, 3 pi over 2, and 2 pi. Those values stayed the same. You find the reciprocal of 1, and you just get 1. So this point just stays where it is. Same thing for negative 1. The reciprocal of negative 1 is negative 1. So that becomes a point 2. It just stays where it is. So we're starting to build our cosecant graph, right? Now the question is, what happens in between these asymptotes? We have these points. What happens there? Well, we did the same thing for tangent, right? If you were to type in the cosecant of any angle in this area in between 90 and 180, right? Remember, to get cosecant, you have to take in your calculator 1 divided by sine of that angle. So if you typed in 1 divided by sine of 145 degrees, you would find that that value is pretty large. We start going in positive y direction. And as we get closer to the asymptote, it jumps up quite a bit. And so the graph ends up looking like this. If you test out those same angle measures in any of those little intervals there, then you'd find that the cosecant graph just kind of takes a U shape, and it turns in the direction that the point is already in. So if the point's, positive, then the U goes up, and if the point's negative, then it goes down. So the U's turn away from each other. And that's it. That's your cosecant graph. Okay? So really the moral of the story is plot out your points for sine. Everywhere you have an x-intercept, make those asymptotes, and everywhere else the points stay the same, and that just tells you how to turn your U's. Okay? So let's try it in some of the ones that you have in your notes. This one first. So in terms of sine, right, same thing, amplitude's going to be 3. The period here is still going to be 2 pi, but now divided by pi, which gives you 2. Your x values. You got to take 2 and divide it by 4, so that's a half. So you go a half, 1, 3 halves, and 2. And that's all we need, right, to label our x-axis. So sine graph starts at 0, and the amplitude is 3, so the next point goes up to 3, then 0, then negative 3, then 0, and we can keep going if we wanted to. We go in the other direction. And so, again, the trick here is everywhere you have an x-intercept becomes an asymptote for cosecant. Right, which means that we can get rid of those points now. And everywhere you have a point off of the x-axis, that becomes a point on your cosecant graph. And then we just turn the U's away from each other. And those points become the minimums in those little intervals, right? And maximums. There you go. That's it. Hopefully that makes enough sense. You try number 2. Stop the video, get it going. I'll show you the graph, walk through it, and we'll move on to secants. All right, so this is what you should have gotten, right? The amplitude is 2. The period is pi over 2, which makes your x values 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Now, this was negative 2, right? Negative 2 was the A. So, pay attention to the fact that the very first window to the right of the y-axis, your U went down, and to the left it went up. It's a little bit different when A is positive, but hopefully your graph looks like that. If not, come find some help, right? All right, now we turn our attention to secant, and secant is based off of a cosine graph, and cosine graphs are pretty much cosine waves are pretty much sine waves, just starting at different points, right? So our process is going to be the same, right? We're still going to take the amplitude, we're still going to find the period, which is going to be 2 pi over a half, right? Flip that over and make that 2 over 1. Make that a little bit neater. So multiply by 2 over 1. 2 pi times 2 is just 4 pi. So your x values become, got to divide that by 4. So 0 pi, 2 pi, 3 pi, and 4 pi, right? Okay, which is going to help us label the x-axis. But secant is based off of cosine, so just graph a cosine wave. Cosine starts off of 0, starts at the amplitude, so which is 2. And then we know the pattern. It goes to the x-axis, then negative 2, the x-axis, and back up to positive 2. And the other way, it's the same deal. But just like sine and cosecant, if you want to find the value of secant, you've got to do the reciprocal of sine. So again, every time you take the reciprocal of 0, you get undefined. So that means, again, everywhere we have x-intercepts, which is where the value is 0 for cosine, that's where we're going to get an asymptote for secant. Okay? And if you do your reciprocal and then multiply by 2, all of these points are going to stay the same, just like it did for cosecant. And that's going to help you create your u's. And so now we just draw in the u's. Okay? And so there you go. There's that first secant graph. So it's the same thing. Everywhere you get x-intercepts, there's going to be an asymptote. The other points stay where they are and become the way to help you make your u's. Okay? Oh, don't want to show you that just yet. Now that you've seen it. Pause the video and try that next one on your own. And then you can start the video back up. I'll show you that graph again, and you can check your work. So, does it look like this? Someone asked in one of the other classes if the sketching in the dotted cosine graph was necessary, and it's not. You don't have to. You can if it helps you. That's fine. It's not necessary. So make sure your x values are correct. Your u's begin and turn the right way and all that kind of stuff. And if they don't, make sure you come find me for some help. Okay? All right. Now, tangent and cotangent, right? It's the same thing where we want to base a cotangent graph off of tangent. So let's do this. Let's plot some points, and tangent graphs have asymptotes. So let's plot those for tangent. So 1/2 tangent 2x. Our amplitude is going to be 1/2. Period. Remember that for tangent, the period is pi, so we got to take pi and divide it by 2. So that's your period for that graph. And then your x values, right? Take pi over 2 and divide it by 4, which means multiply by 1/4. So pi over 8. And so your x values are 0, pi over 8, 2 pi over 8, which reduces down to pi over 4, and then a 3 pi over 8, and then a 4 pi over 8, which reduces down to pi over 2. And just like before with tangent, we always put an asymptote at the 2nd and the 6th tick mark. We're going to do the same thing here, 2nd and the 6th tick mark. And then we can start plotting our points. We know that tangent 0 is 0, and then since the amplitude is 1/2, we're going to go to positive 1/2 to the right and negative 1/2 to the left. And that's the pattern that we'd use for all of our little windows here, okay? But think about this again, right? Wherever there's an asymptote, that's where your value of tangent is undefined. For cotangent, we would want to take the reciprocal of undefined. The reciprocal of undefined is 0. So where the sine and cosine graphs, we used all the x-intercepts to create asymptotes, we're going to kind of go backwards here. Everywhere you see an asymptote becomes an x-intercept. So this guy right here turns into an x-intercept. This guy right here turns into an x-intercept. This guy right here turns into an x-intercept. And so does this guy. And everywhere you see an x-intercept for tangent becomes an asymptote for cotangent. So right here is an asymptote. Right here is an asymptote. And right here is an asymptote. Do that a little bit better, right? And we can get rid of those points. And now the remaining tangent points are going to stay on the cotangent graph. And it kind of gives us an idea of where this curve goes, right? And so it comes like this. Not exactly the best curves, but you get the point. So there's your cotangent graph. Cotangent graphs look a little bit like negative tangent graphs. Okay, but remember, we got to label our x-axis. So this is pi over 8. Pi over 4, 3 pi over 8, and pi over 2. We want to make sure we do that because we can ask all kinds of questions. It's important to know What angle measure gives you asymptotes? What angle measures gives you, angle measures give you a value of 0 for cotangent, right? And for this graph right here, for this function, we could find out what angle measures give you asymptotes. Well, 0 does, right? Because there's an asymptote right there. And pi over 2 does, because there's an asymptote right there. What angle measures give you a value of 0? Well, there's one right here, so pi over 4 apparently does. So does negative pi over 4. So, we want to label the x-axis so we remember what those values are. Okay, but anyway, that's how you get your cotangent graph. Asymptotes from tangent become zeros for cotangent. Zeros from tangent become asymptotes for cotangent. Oh, did it again. Right? There's one more for you to do. I'm getting all messed up here. So go ahead and stop the video and start it back up. And then you can see how that next one's graphed. Okay? So go ahead and stop the video and bring it back up and check. And that's what your graph should have looked like, right? If you do your graphs in pen, then you're going to want to set the asymptotes for tangent, so that'll help you create your zeros for cotangent and vice versa. So then you would have those asymptotes of tangent in there with the asymptotes of cotangent. But if you're doing it in pencil, which I think you should, and obviously when you're doing your homework on your iPad, you can erase the asymptotes. Try to not show the asymptotes from tangent, just a little less confusing. Okay? But any issues getting to that graph, definitely come in, sit down, and we'll go through it. Okay? But otherwise, your homework's sitting out in Canvas, so get that done, and we'll go over it next time.